Hey everybody, thanks for joining me. In this video, I am going to guide you through an example as we graph a transformed tangent function. So let's get to it. Before I write my example, I want to take a minute to draw out what tangent looks like, positive, and then what it looks like, negative. I didn't do that in the other video because it took a while to talk about other things. And I've done it for the other trig function, so I think it's important we do it now. Y equals tan x. I'm going to really make this line much longer than I usually do. And then y equals negative tan x. Again, the reason I make it a little bit longer is there's a lot going on with the extra tick marks, and you want to be able to see everything pretty clearly. And if you really stretch out the horizontal distance over which, literally over which, you are analyzing this and drawing this, it just gives you more space to really get a good look. Okay, so I'm going to go in and label 2 pi, find the midpoint, that's 0, find the midpoint of pi, find those midpoints. So this is pi over 2 and 3 pi over 2, and then last but not least we'll find all of their midpoints, and we get pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, there you go. From here I'm going to put on the 1 and negative 1 on my y-axis. Can you see? Yeah. All right. And we'll do the same over here, a little squished because I didn't make it as long. So 2 pi. And maybe you'll even see the pros and cons, like what this will look like, because it is not as long. Okay. So they're both pretty crowded, but just got a smidge more room, right, on that one. So we put in the zeros, the asymptotes, and the ones. So the zeros, I believe I put in orange, and tan, the meditating man, right, it was 0, at pi, at 2 pi. And if I make it negative, does that change the zeros? No, does not. Negative 0 is still 0. So that does not change. Next up, I will put in my asymptotes, my vertical asymptotes. They were in pink, undefined, everything in his mind, all his thoughts and all the people below him. He could not define them. If you don't know what I'm talking about, tan, meditating man, please go find that video. I will try to eventually update and put it in the description box underneath the video. But those are the top and bottom angles on the unit circle. Now what's the negative of undefined? Guess what? It's still undefined. So this does not change, all right? These components, these details are the same. What changes are all of the answers. So the 1, except the zeros. 1 and negative 1 will really guide us and dictate us to what we need to do. So when tan's positive, that's quadrant 1, it's positive. Quadrant 2 is between pi over 2 and pi. So down here it's negative 1. That was positive 1. This is quadrant 3, between pi and 3 pi over 2. So there's positive 1 right in the middle. Quadrant 4, negative. All right, and then I think I just drew the graph in purple, but purple marker is not great. It's kind of dry. So I'm going to go right there. It should be like concave up. It's not looking too concave-y. Here, that was a little bit better. And then that was concave down, and then this little scoop, it's concave up. It'd be a little bit better if I had left myself more room above it. And then down here, concave down again. So 2 cycles, this and that one right there should look alike, okay? So there we go. How will this be different? All my 1s are negative 1s. And all my negative 1s are 1s. There we go. I never labeled this, but do our best. Draw in our little squiggle guys. So take a minute, get that down in your notes, and look at it. Think about it. Does that make sense? Can you come up with any tricks or something to help you remember it? And remember, the tricks, you want them to still work after we do cotangent, so it's a little interesting. But don't forget, when we get to cotangent, it starts with the C. I did give you a trick about the C's. Now, the common mistake is if I ever present a graph like this and I ask people to write the equation, they're like, oh, cotangent. It's just negative tangent. Sometimes it's cotangent, sometimes it's negative tangent. It has more to do with the orange and pink that dictates tangent, cotangent. So keep that in mind. All right, let's make up an example. Let's graph y equals, let's just do 1/2 tan. Let's spice it up this time and do 4/3 for my b value. I don't know what to put. All right, there we go. So my equation is y equals 1/2 tan of 4/3 times quantity, x plus 6pi over 5 plus 7. Let's get going. First thing I'm going to draw is my sinusoidal axis. I'm going to draw my dashed line, or actually, yeah, this time, yeah. I feel like I usually draw the shape first. Maybe I should. I feel like it's just so awkward to draw that without the sinusoidal axis on it, if that makes sense. But no, I guess I'll still do the shape. So I'm going to draw this right here. It's positive tan, okay? Then the next spot will be up because it's positive, even though there's a 1/2 there. Then the next distance apart, we're going to have an asymptote. Then the next spot, see, I feel like you need that dashed line. See, I'm going to do it. I'm going to do it. I didn't want to stray from my usual strategy, but sometimes you got to make an executive decision. So first I dealt with the plus 7. I knew my gut was right. It's too awkward to know what's on top, bottom, where everything is. So now, same distance over, okay? Just eyeballing down, then on it. See, I'm here, here, up. Then below and there. My spacing's not perfect, but there we go. We have our skeleton done for tangent. We can connect it. There we go. So what have I addressed so far? Plus 7. And I also addressed the fact that it is positive and the fact that it is tangent. Next, we can kind of label a little bit. So this blue dashed line over here is the line of y equals 7. Since the vertical compression is 1/2, that means that this point that was normally a 1 is actually 7.5. And then this point here that's usually, say, -1, ooh, it's not really, here we go, is 6.5. But again, those are just off to the side. I don't know where my axes are yet, okay? Next thing, so that dealt with the 1/2. So it's sort of like an amplitude, but you know, we don't have a measurable wave. So it's really showing that distance to the sinusoidal, okay? That's what we're measuring with that 1/2. Next up is the h. which is plus 6 pi over 5. And since it's normally minus in the equation, that means that my first spot, my first tick mark, is going to be at the point of where x is negative 6 pi over 5. So I'm just going to go here. Now this pink dotted line is not an asymptote, right? It's dotted lines are not really on the graph. Dotted lines are just there to help you draw it. Sometimes they're here to help you draw it as an asymptote. Sometimes they're there to help you draw it so you know where something is. You have to know their purpose, okay? Then I could draw my y-axis. I'm sorry, I always say y when I mean x because I see my y values are all positive. So I'm just going to go somewhere below. I'm going to go right across horizontally so I can get these tick marks on there. That's my x-axis. And I'm going to label my 9 tick marks. 1, 2, 3, 4, 5, 6, 7, 8, and 9. That one right there, I'm leaving a little room. It's negative 6 pi over 5, and I might have to find a com to num. That was taken care of. What color did I do? Oh, pink. Now the 4/3. 4/3 is the b value. Remember, when you tan, you're going to cut back on the pi. So the period is pi over b. B is 4/3. Dividing by 4/3, dividing by a fraction, is the same as multiplying by the reciprocal. So all I'm going to do to make my life better is you're going to do pi times 3/4, which means then obviously the period is, you could just use 3 pi over 4. Ooh, I picked bad numbers, guys. Sorry. 3 pi over 4. I still want a quarter of that. So, sorry, I write all over the place. Quarter of it is 1/4 of it. What is it? It is the period of 3 pi over 4. And that means our quarter period is 3 pi over 16. So this denominator is 16. That denominator is 5. So if you knew right off the top of your head that your least common denominator is 80, go you. You're a genius. If not, I'm sorry, it's 80. It's going to be a little annoying. So 16 times 10 is 160, and 80 is half of that. So that means I'm just going to multiply on top of 1 by 5. And sometimes that's the method people use anyway. They're like, I'm just going to give this one what that has and that one what that has. Yeah. That's not always your least common, though. And this one then will be 16. Whenever I multiply by 16, I just think of it as times 2, times 2, times 2, times 2. Like multiplying by 2 or doubling something 4 times, since 2 to the 4th is 16. Picking up what I'm putting down? Maybe. So my quarter period, and I should probably kind of write it nicely somewhere, so I'm just going to put it over here. The quarter period with the denominator of 80 will be 15 pi over 80. And my age, which is where I'm starting, will be, so 6 times 2 is 12 times 2, 24 times 2, 48 times 2, 96. So my age is negative 96 pi over 80. I'm starting at negative 96. I'm going to add 15 each time. Negative 96 pi over 80. Okay, plus 15. So it would be negative 86, negative 76, negative 81. So negative 81 pi over 80. Next, another 15. So 10 more, negative 71. 10 more would be negative 61, 5 back, negative 66 pi over 80. 15 again. 56, 5 more, 51, negative 51 pi over 80. There is a negative in there, just a little blended. 15 more, 10 would be 41, 5 more, I'll just do 10 more, 31, 5, 36. Negative, sorry, the way my brain works, that's how I want to do it. 36 pi over 80, 15 more, 36, 26, 21, so negative 21 pi over 80. I don't know if we're going to cross over, maybe 15 more. is 10, 11, so 10 more, 1, put back 5, negative 6 pi over 80, and somewhere over here we're going to cross over to positive, plus 15 more, that's 9 pi over 80, and 15 more, 9 and 15, 24. Whew. So what does that tell me? I could draw my y-axis. Hooray! It's just going to be in there. Okay, that is 7, 7.5, 6.5, a little zigzag for a break, and maybe label the y for the axis. That goes there, up there. Go you. Beautiful. So take your time going over this. I know the numbers were crazy. I did want you to have to find the common denominator. I didn't want it to be that crazy. But I'm going to spice up the example that I want you to do on your own. It's going to be a little interesting. So let's see how this goes. So on your own, why don't you try y equals negative pi, what? Tan. I've been doing plus a lot for these because it's just annoying to fit graph when you shift everything down, you know? There you go. All right, so some interesting stuff there. Let's see how you do. So you're going to graph 2 full cycles of this tangent function right here on your own. And if you persevere and just really follow through, you can do it. I know it looks weird, but it's actually going to work out super nice compared to maybe some of the other examples. So if you feel decent about this, thumbs up. If you feel less than decent about that, maybe a thumbs down. Don't worry, my feelings won't be hurt. All good. And have a really nice day. Bye.